In this video, I will explain how to use the fixed point iteration method to approximate the root of a function. So let's jump right into an example. This says, use the fixed point iteration method to find the root of f of x equals x cubed plus 2x minus 5. So when we say we want to find the root of a function, all we mean is what is the x value that will make this function equal to 0? So what value can we plug in for x that when we plug it in, f of x turns out to be 0? So just as a visual aid, if we were to graph this function, here's what it would look like. So the x value that actually makes this function equal to 0 is about 1.3283. So when you plug in this value into this function, the output is about 0. So the fixed point iteration method is just a way to find this x value. So here's how this method works. The first step is we need to set our function equal to 0. Then we need to solve for the x variables in the function. So for example, if we solve for this x variable right here, to do that, we could move the 2x to this side, move the negative 5 to this side, and then take the cube root of this side. So here's what that looks like. So x would be equal to the cube root of negative 2x plus 5. Now, if we were to solve for this x variable instead, we could move this negative 5 to this side, and we could move this x cubed to this side, and then we could divide by 2 to get this x by itself. So here's what that looks like. Now, these two equations that we've just created, we refer to these as g of x equations. So the whole idea behind this fixed point iteration method is that we're going to pick one of these two equations to start with, and we're going to pick an initial x value to plug into the equation, and whatever result we get, we're going to then plug it back into the equation again, and we're just going to keep repeating the process over and over until it looks like we're starting to converge on our root. Now, there's no guarantee that both of these functions will converge towards the root. So if we find that we pick one of the functions and it's not converging, we might have to switch to the other function and try that one instead. So to start with, let's choose this as our g of x equation. Now for our initial x value, let's call it x sub 0. This is just an arbitrary pick. So for this example, let's just pick a value of 1 and see what we get. So we're going to plug in a 1 into this function right here for x and see what we get as the output. So when we do that, we can say g of x, well, we're plugging in a 1, so let's say g of 1 is equal to the cube root of negative 2 times 1 plus 5. So this is negative 2 plus 5, that's a positive 3. So this is really the cube root of 3, which turns out to be about 1.4422. Now what we're going to do is take this value and use it as the next x value that we plug in. So we'll say our x1 value is 1.4422. So we're going to plug that value into our g of x equation. So we'll say g of 1.4422 is equal to the cube root of, we have negative 2 times 1.4422 plus 5, and that turns out to be about 1.2837. So now we'll take that value and use it as our next x2 value. So when we plug that into g of x, here's what we get. So we end up with 1.3449, which we can use as our next x value to plug in. So let's go ahead and do that. So this turns out to be 1.3219. Now, what we'll notice is that during each iteration, our differences between the iterations are getting smaller and smaller. And what's happening is we're actually converging towards this true root of 1.3283. So if you did even more iterations, you would just get closer and closer to this true root value. And the point where you decide to stop doing more iterations really just depends on how small you want the error to be. So once the difference between the iterations gets small enough, you may decide to just stop. So that's the idea behind the fixed point iteration method for approximating the root of a function.